Today we go through chapter 12, which is on MRP and ERP. We'll look at inputs, outputs, nature of MRP processing, benefits and requirements of MRP, and then what is the difference between MRP and MRP2, and then finally ERP. So starting with MRP, materials requirements planning. Materials is a part of any operations management, and materials have to be managed. So material requirements planning, as you can see here, it is a computer-based information system. Because nowadays we have a lot of advances in computer technology, and since computers can do repetitive things much faster, so MRP uses computer-based information system. The calculations which it needs to do are very basic, but because of complexity of the products involved, it makes sense for people to use computer-based systems because there could be a lot of human errors if computers are not involved. So it is a computer-based information system that translates master schedule requirements for end items into time phase requirements for subassemblies, components, and raw material. So it starts looking at the end product and then breaks it down to the smaller ones. Like if you think of a car as an end product, then it's other sub-assemblies like engine, transmission. Then within engine, there could be so many different parts, fuel injectors and things like that. So MRP basically goes into details of all that. It goes basically up to the component level. Now, one has to look at like what is the nature of demand which a company is trying to meet. So there are basically two types of demands. One is independent demand and other is dependent demand. So as the name suggests, independent demand is like, I can give one example of, let's say, car. So for a big auto company, let's say they need 100,000 cars in a year. So they have to make 100,000 cars in a year based on the forecasted demand. So that is an independent demand. Dependent demand is that for every car one makes, most of the car you'll see has 4 wheels, and each wheel requires a tire. So if you look at a tire requirement, or somebody wants to predict demand for tires, so it is going to be very straightforward. You multiply 100,000 by 4, so the demand throughout the year for the tires is going to be 400,000. That's why independent demand, that comes from the market or customers, and dependent demand, so it is based on the first one. So once you know how many end items are needed, then dependent demand can be easily calculated. You multiply by 2, 4, depending on how many you need per finished product. So independent demand is uncertain because of the market conditions, customer or consumer patterns, changing patterns. So those things, and also like economy, so all those things create uncertainty. If the demand next year is about 100,000, there's no guarantee that after 2 years it is going to be 100. It could be maybe 50, it could be 200. So there's a lot of uncertainty involved, but dependent demand is certain. So once you know how many finished products are needed, then you simply multiply by appropriate number. A dependent demand, this is the demand for items that are sub-assemblies or component parts to be used in production of finished goods. So when we go into like details of how many components will be needed of every variety, so then you have to look at all these things. So once independent demand is known, the dependent demand can be determined. So by determine, it can also mean it can be calculated very easily. If you compare dependent versus independent demand, you'll see that generally we have stable pattern over a period of time, whereas dependent demands, they are lumpy. So they just come in like almost in batches because there's a lot of certainty involved. Big company, when they place order to a smaller supplier, they will give them a big number, and then suddenly for some period there won't be any demand from the bigger manufacturer, and then again the batch of demand comes. It also actually can be affected by the seasonality. So if somebody is in a business of making like two type of equipments, one related to maybe winter season and other one maybe summer season, so demand to this company can be affected by that also. So suddenly they will see an increased demand maybe in summer, whereas less demand in winter. So that makes dependent demand pattern more lumpy. And also the amount of inventory to be kept, actually we may need a safety stock. So that is always a variable when you are dealing with independent demand. But with dependent demand, you don't have to really think in terms of a safety stock. Now coming to the overview of MRP. So you can look at this overall picture here. So MRP computer programs, they are at the center, and there are three main inputs. The first one is master schedule. So master schedule we have talked about earlier also. What it tells is how much finished product is needed and when it is needed. So when customers need those items. So that information comes as an input to MRP system from master schedule. The second major input is bill of material. So bill of material basically gives composition of the finished product. So let's say if we are talking about a chair as a finished product, then bill of material goes into details of like how many legs and how many other parts will be needed. Third one is inventory records. So that also is a critical input because that tells what is already available. So if a customer requires, let's say, 100 items in a period, and you have already maybe 80 items in the inventory, then that is a critical information to know. Now, MRP gives broadly two types of reports. One is primary and the other is secondary. So in primary reports, you have plan order schedules, and in the secondary, you could have performance control reports and inventory transactions. So we'll talk about these in more detail. So coming to the inputs, so as you know, there are three key inputs: master schedule, bill of material, and inventory records. So let's look at the first one. So master schedule, it is one of the three primary inputs in MRP. So it states which end items or finished products are to be produced. So it gives answer to a question in the form of which is which here, the word which, and then when. So that's the second W, when these are needed, and third W is what, in what quantities. It also looks at the cumulative lead time, the sum of the lead times that sequential phases of a process require, from ordering of the raw materials or parts to completion of the final assembly. So it incorporates the whole process of ordering the material till the completion of final assembly. So that is a cumulative lead time. So there could be so many different processes within that. In fact, next slide gives that idea here more clearly. So this is the planning horizon for master schedule, which includes the complete or cumulative lead time. So starting from the procurement, so let's say it takes 2 weeks, and then fabrication takes 3 weeks, sub-assembly about 2, and then final assembly about 2 weeks. So cumulative lead time will be 2 here, 3 here, 2, and 2. So 9 weeks is the cumulative lead time. Now coming to bill of materials. So this is one of the 3 primary inputs of MRP. The first one being, as discussed, master schedule. So it is a listing of all of the raw materials, parts, subassemblies, and assemblies needed to produce 1 unit of a product. So please remember, bill of material is basically gives details about just one product. So if a company is making, let's say 10,000 or 100,000, they can multiply appropriately. But bill of material only provides the details of 1 unit, like 1 chair will need what all different parts. So to apply bill of material concept, sometimes we use what is called as product structure tree. So this is visual depiction of the requirements in a bill of materials, where all components are listed by levels. So there is a low level coding. So restructuring the bill of materials so that multiple occurrences of component all coincide with the lowest level at which the component occurs. So this is a technique or coding used to make things simple. So if you look at a product structure tree as an example on the next slide. So this is about a finished chair. So this is the finished item, and it breaks up a chair into 3 major parts. So front legs, and then the seat, and then the back supports and related parts. So this is the assembly diagram. And if you look at the product structure tree here, so chair has been broken into 3 parts: leg assembly, seat, and back assembly. Now within leg assembly, 2 legs are needed per chair and 1 crossbar. For back assembly, side rails required will be 2 in number, and back supports 3 in number. So using these, one can easily calculate if the demand is, say, 10,000 for a year, then how many back supports will be needed, or how many legs will be needed. So this is just a brief example. So in this chapter, actually, we don't go into too much of details about each of these concepts we are talking, like bill of material or master scheduling. Actually, more detailed coverage is provided in our materials management class, which is for operations management majors. Now coming to updating the system. Now please remember that MRP is, let me write down, is not a static document. So it is not a static document. In fact, it is a live document. The reason is orders which we receive from the customers are at different stages at different times. Maybe some are complete, some are near completion. There could be new orders, there could be changes. So many things are going on at the same time. So all such information which keeps on changing, MRP has to keep everything current. So what was like valid maybe 2 months ago, if it is not updated, then the system falls flat actually. So there are 2 methods people use. One is a regenerative system, which updates MRP records periodically. So maybe at the end of every day, or whatever company follows. Or it could be net change system. So updates records continuously. So anytime there is any addition or deletion in the system, that gets updated immediately. Now coming to MRP Primary Reports. So in that overview, there were 2 basic categories, primary and secondary. So this is the first one. So in the primary reports, we have what is called as planned orders. So schedule indicating the amount and timing of future orders. So whatever has come from the customers. And then there are order releases, authorization for the execution of planned orders. Planned orders are just orders which has been planned, but somebody has to execute them. So for example, if a purchase order has been planned for maybe third week of a month, then when the third week comes, somebody has to place that purchase order to the appropriate supplier. So that execution is also needed. And then it also has changes, revisions of due dates, order quantities, or cancellation of orders. So all that is part of MRP primary reports. Now in the secondary reports, we have things like performance control report. As the name suggests, these reports are useful to understand what's going on, how much control we have, and how we can improve. So it measures deviations from plans. It could be missed delivery. It could be even stock out situation where a customer places an order, but because we don't have that product in the stock, we are not able to fulfill. The second one is planning reports. So this is useful for forecasting future inventory needs. So how much will be needed? So it is used for that. And then there is an exception report. It addresses basically things which are, let's say, late or overdue. So those kind of orders are addressed here. Now MRP, although you may come across more examples in manufacturing area, but it has also been very useful in services. So two examples are actually given on this slide. The first one is a food catering service, where end item is the catered food. And dependent demand, you have the ingredients for each recipe, which is basically captured by bill of material. Second example is a hotel renovation. Activities and materials exploded into component parts. So exploded means broken down into component parts for cost estimation and scheduling. So you can see that MRP is also useful in services, not only in manufacturing. So there are many benefits of MRP. One is it reduces in-process inventory. So the need to keep more inventory is when we don't have the right information at the right time, like which components are needed, and then placing the order so that it reaches in time, keeping in mind the cumulative lead times. So if everything is working nicely, then obviously it will lead to less and less in-process inventory. Ability to track material requirements. Ability to evaluate capacity requirements. So that is another benefit. Means of allocating production time. So because we have the details in MRP about each and every part needed, so a production time can be allocated for each and every part and activity. Ability to easily determine inventory usage by back flushing. Back flushing is exploding and end items bill of material to determine the quantities of components that were used to make the item. So in a way, those things can be calculated. Now let's look at to have a successful MRP system, what requirements one has. So obviously, computer and necessary software is needed to implement MRP, because keeping like file records is going to be very tedious and time consuming and also prone to error. So a computer and necessary software is going to be required. Accurate and up-to-date master schedules, bill of materials, and inventory records. So even if you have the most powerful computer systems and softwares, but if let's say inventory records are not up to date, then it is going to create a lot of problems. What could happen is there could be too many or too few parts ordered if the records are not correct, and there could be failure to be on schedule if all this information is not available. So integrity of data is very, very critical. So that was actually brief introduction to MRP. Now let's look at MRP 2. MRP2 actually stands for Manufacturing Resource Planning. So this MRP actually does not replace or improve MRP. So it is basically, MRP2 basically expands the MRP. You can see expanded MRP with emphasis placed on integration with financial planning, marketing, engineering, purchasing, and manufacturing. So that's the idea of expanding it. So you can see here, MRP actually is at the heart of the whole process here. Finance, marketing, market demand, manufacturing, all that they collaborate and develop what is called as a production plan. And then there is a rough cut capacity planning. And if there are problems, then it goes under a number of iterations. And if there's no problem, then it moves on to master production schedule. And that sends the input to MRP. And then it goes to capacity planning. And if there are problems, then again there is iteration within this loop. Otherwise, it goes to requirement schedule. So you can see MRP2, which is manufacturing resource planning, it is much more expanded than MRP. Now coming to capacity requirement planning. So as we had seen in the previous slide, MRP2 assists managers in planning capacity requirements. So capacity requirement planning, as we had seen earlier, is the process of determining short-range capacity requirements. So there are load reports where department or work center reports that compare known and expected future capacity requirements with projected capacity requirements. So we try to balance them. And we also talked about time fences when we went through the chapter on capacity planning. So if you look at this flow chart here, so it starts with develop a tentative market production schedule, use MRP to simulate material requirements, then convert material requirements to resource requirements, which is the load report, and then ask a question, is shop capacity adequate? So if the answer is no, then we go to, can capacity be changed to meet requirements, like by doing overtime or subcontracting and things like that. But if the answer is again no, then it goes back to revising tentative master production schedule and then going back to the loop. But if the answer is yes, then form up a portion of MPS, master production schedule. And if the capacity can be changed, then change the capacity, like do some subcontracting or overtime and things like that. So actually, you can see MRP2 also provides a good way for doing what-if kind of analysis for the managers. So they may see, what if we go for overtime, or what if we go for subcontracting or some other changes? What could be the result? So coming to the third topic in this chapter, which is ERP, which is Enterprise Resource Planning. So this is actually the next step in the evolution that began with MRP and then developed into MRP2. So MRP2 was expanded version of MRP. And ERP is basically, as the name suggests, it is enterprise-wide resource planning. So integration of financial, manufacturing, and human resources on a single computer system. So there are very well-known ERP softwares. So ERP software provides a system to capture and make data available in real time to decision makers and other users in the company. It also provides tools for planning and monitoring of various business processes. There is a reading assignment for this chapter, the ABCs of ERP. So once you go through that, you'll see that it provides much more detail about ERP. So actually, ERP initially was developed for manufacturing, but people have also found applications in service areas. So service applications, some examples are given here in professional services, postal services, retail, banking, healthcare, higher education, engineering, logistics services, and real estate. So there are so many different areas in which ERP is being used nowadays